Event sourcing is an architectural pattern utilized in software development and distributed systems, where the state of an application is determined by a sequence of events rather than storing the current state as a single record in a database. In event sourcing, each change to the application's state is captured as an immutable event. These events represent meaningful actions or facts that have occurred within the system. Instead of updating the state directly, new events are appended to an event store in chronological order. This is fundamentally different from the traditional approach, where the current state is stored in a database and updated whenever a change occurs. Some key characteristics of event sourcing are immutable events. Events cannot be altered or deleted once stored, ensuring an auditable record of all changes made to the application state over time. Event store. Events are stored in an event store, which is an append-only log of events. The event store is the single source of truth for the application's state. And state reconstruction. The application state can be reconstructed by replaying all of the events from the event store. This allows for a comprehensive historical view of the application state and supports features like time travel debugging and auditing. Some benefits of event sourcing are auditability. Event sourcing provides a complete history of all changes made to the application state over time. This allows us to easily audit the system and understand how the state has evolved, where errors might have occurred, etc. Time travel debugging gives us the ability to replay events and enables developers to time travel and debug the application at any point in the past, simplifying issue diagnosis and resolution. And lastly, scalability. Event sourcing allows us to scale the read and write side of the application independently. So while event sourcing has many benefits, as anything else, it also comes with some drawbacks. One being complexity. Event sourcing is a complex pattern that requires a lot of boilerplate code to implement. This can make the project difficult to understand and maintain, so always consider the trade-offs before using this pattern. And also, eventual consistency. The read side of the application is eventually consistent with the write side. This means that there might be a delay between the time an event is written to the event store and the time it is processed by the read side. As we mentioned in a previous lesson, event sourcing is often used in conjunction with the CQRS pattern, which we have of course started implementing in this course. In this case, the write side of the application is responsible for storing events in the event store, while the read side is responsible for reading events from the event store and updating the read model accordingly. In the next lesson, we're going to move past theory and the pros and cons and learn how to actually implement event sourcing in our Nest.js applications.